Hi, my name is Surajit Ghosh, and in this video, I'll talk about the correct design command sequence required to optimize any steel structure using STAAD. This is the second part of the steel optimization series. In the first part, I have covered the general overview of select command and discussed how and why we should use this. If you have not watched the first part yet, please go through that to understand the full concept of optimization. Link is provided in the description. When select command is used in any STAAD model for steel design, program performs an iterative design to find the most economic section required for that loading condition. In this process, the assigned section is modified and a new section is selected. Now, if you terminate the design at this stage, your design will be incomplete and might be unsafe. There are certain points you need to keep in mind if you want to use select command. Instead, stiffness method is followed to analyze any structure, and on basis of that, section forces are calculated. When the assigned section of a member change, there is a change in stiffness as inertia value is modified, and that will further change the load acting on that member. To understand this, consider this simple goalpost frame where I have applied a UDL on the beam. This structure is symmetric and both the column has same section. If you look at the section forces, all force values are identical for these two column members as load is equally distributed. In the next model, I have assigned higher section to one column and reduced the section of the other column. Now you can notice, though the load and other structural conditions are symmetric, still column with heavier section is subjected to more forces compared to the thinner section. This is the basics of structural analysis. More steep members with higher inertia value attract more forces, right? If you use select command and sections change during design, change in force is not considered during design iteration, and it might happen the economic section suggested by the program may fail when the modified forces are considered. So it is always suggested to analyze the model once again after the section selection is complete and then redesign to check whether the selected section is adequate for new design forces or not. The correct sequence for section selection is first use select command, followed by perform analysis command, and then perform design using checkcode command. The final design ratio reported considering the modified section size and with modified section forces. This is the correct sequence to consider modified forces during optimization. During section selection, program always tries to find a section with critical design ratio close to the allowable ratio or 1. But it is always better to use a safety factor so that full section capacity is not used for section selection. If program selects a section with ratio 0.99, then there is a high chance due to any increase in member forces that section fails. Normally for member selection process, we instruct program to select a section with allowable design ratio close to 0.9 or 90% of the section capacity is utilized. This can be specified using the ratio parameter. Before member selection, you can define ratio 0.9, and in this condition, program selects a section with ratio close to 0.9 with 10% capacity in hand. In most of the cases, This reserved section capacity also eliminates the first problem, member failure due to modified section forces. So, correct sequence for section selection is define ratio 0.9 along with other design parameters, use select command, and then perform analysis command. Finally, you can specify ratio value as 1 and use check code command. Sometimes it is required to use the same section throughout the member span just to maintain proper connection and ease of work. A common example is top or bottom chord member of a truss. Though the section utilization varies over length with same section size, still we use uniform section for the chord members. When you use select command for these members, program selects different sections depending on the utilization ratio, which is not the favorable condition that we are looking for. In such case, you need to inform program to select same section for all these members using group command. This command can be assigned from the design command window. When you assign group command to certain members, program creates a virtual group and performs normal iterative section selection. After member selection, if different sections are selected, then highest section size is assigned to all those members present in that group. Check this truss model. First, I have used select command without any group, and you can notice different sections are assigned to these members. In next model, I have used group command with all these members present in the top and bottom chord. This time you can notice the highest section required for any of these members is assigned to all the members in the group. So all members have same section size throughout the span. This group command should be assigned after the select command. First, program selects section size for individual member and then assign largest section to the group. If you go to the design commands window, you can notice multiple property specifications are available like AX, SY and SZ. By default, cross-sectional area AX is used as the sorting criteria, which means section with the largest AX value is assigned to all the members. You can also select section modulus for grouping. Also, you can select any member for group property assignment. In this case, section of that member is assigned to rest of the members, but this must be cross-verified using the check code command. To summarize, correct sequence with select and group command is: first, specify all design parameters along with ratio 0.9. Then assign select command followed by the group command. Next, reanalyze the structure. Change the ratio to 1 and perform design using check code command. This is the correct sequence if you want to optimize steel usage and design a safe and economic structure. After section selection is complete, you can notice in the properties table several new sections are added. These sections are selected by the program during design as the most economic section, but not yet assigned to any member. Your original section properties are still intact. Now, you need to go to the post-processing mode, check from the utilization ratio table about the new section information, whether the changes are acceptable or not, and once you are satisfied, simply click on the Update Properties tab. This will assign all the selected sections to relevant members. And this ends the section selection process. If you go to the Properties table now, you can notice all member properties are updated with the new section information. In this selection process, only the sections available in the standard database are used. But there is a way to use custom shapes or sections from other database during optimization. Stay tuned for more updates on still optimization. And if you like my videos, subscribe and share. Thanks for watching.